to send the byte as a 05 and not a 06. That gives the idea, since the name is acceptable protocol version, that it could make a downgrade or something like that. And we was correct. If you just replace the first packet, where it should be 06543221, if you just replace it, the 6 with a 5, we will get an answer from the server that should never happen to, with the 5 value, and consequently, the downgrade happens, and you have, again, the wiki data encryption standard protocol. Well, I know it's pretty fast. I hope you are able to follow me. Well, we also have some special points, like, for example, credentials for Windows to Windows. There are some kinds that the full client do not send the packets with this format, including the acceptable protocol version in some new versions. So our trick to bypass it is simply detect where this packet should happen, and we just inject a fake one with a fake acceptable protocol version, and the client will answer as expectedly. It also works if the Oracle server is a Linux, Windows, or whatever, because you'll be fooling the client itself. So as soon as the client is a Windows, it will works. Now we have another point that is interesting. Since we are able to downgrade to a weak format, weak algorithm like data encryption standard, we are able to apply the famous rainbow tables attacks. How it works? Basically, it's the following. The hash authentication is salted with the username. So what you have to create the rainbow tables? Basically, it have to be focused for some specific users. For example, SIS, system, common administrative accounts, because you can't create the rainbow tables for all of them, else it is impossible. So we generate a rainbow table with a pre-calculated and static out session key that you can choose anyone. We execute the downgrade on the fly during the connection to the OD8 protocol, and we send this static send the out session key. Consequently, the out password will be always the same for the password independently. On this way, we are able to create rainbow tables for Oracle connections that are transmitted on the fly during negotiation between any clients. That's the main idea of the attack. We did it on the lab, and it really works. There's another point. That's the NTLM leakage. NTLM basically is the negotiation. I don't know if you remember, but when I was explaining how works a client and a server communication, there was a PC called the SNS, Secure Network Services. Basically, it offers additional authentication, and this additional authentication can be, for example, the Windows authentication. In other words, you can make, for example, your clients authenticate with their domain credentials on the database. Well, what's the cool is that even if your configuration, you have the standard configuration where your database is authenticating on the database itself, for example, like you have seen on the slides, like, for example, the guy call SQL Plus and pass the user and the password, and these credentials are stored on the database. If you are with Windows clients, this information between Windows clients and Windows servers, this information always goes over the network, even if they are not being used. And it's pretty serious. So, for example, inside this packet, we can take a look that, for example, break these NTLM hashes that are the Windows native hashes can be sometimes hard if you use very complex password with NTLM, session security, etc. So one of the attacks that we implement together is to do a downgrade on the NTLM inside of the Oracle protocol on the way that we'll be able to use the rainbow table attacks too. Well, there's also the same problem that I was talking. If the server is a Linux, IX, or something like that, it will not be able to happen because they will fail on the negotiation between two Windows. So we can trick again the client and make it believe that we are another Windows and force them to leak their NTLM hashes used to authentication. Okay, let's see a demo. I think it will be much clearer how to do it still. Okay, this one? Okay. Whoops, this one doesn't tell us, right?
Yeah, that's right. Yeah, just scroll down.
Yeah, okay. Well, basically, here we have Oracle authentication. It's connected to a 10G database. It's an interactive proxy that is being used to redirect packets. We are redirecting the connect packet, resend, redirect again. Here, we can see the signs of the NTS. As I told you, it means that we have an NTS in place. In other words, we will have a Windows authentication inside the Oracle protocol. And then the acknowledgement, the server side agrees that they will be authenticating, and the NTS will be in place. It's very important to know that this authentication is a normal authentication. They are authenticated with users that are stored on the database, not on the domain controller. So it's the native way that Oracle happens. Then we can see the sign of the NTLM SSP that is in the protocol. And consequently, we can see the flags used to negotiate inside the NTLM SSP protocal. Well, take a look at that byte we changed. That byte basically is sent to the client that we use an old version, and we want to use it. We will be executing the downgrade itself that will allows us to insert a fake challenge key, pre-calculated to say the truth, that can be used to execute with rainbow tables. You can see that it works because of the 8.2. They acknowledged with your requested version of the authentication. And that's the challenge key that is kind of handled from the server. We will be replacing it with a static one, like 0, 0, 1, 1, 2, 2, 2, 2. In the case, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8. OK, and we send this packet back. We can see on the sequence the informations, like the hash. Whoops. What happened?
It went on sleep now.
No, it's working here.
There you go.
OK. Well, basically, we are copying a file, the credentials obtained, the username, administrator, as we can see on the first spec on the connect, Spider Labs, that in this case also we can see here on the packet, the challenge that we injected, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, blah, blah, and the password hash itself on the NTLM format. Pretty fast, man. OK, we have the hash completed. Now we will be importing it in a password recovery tool that's also free available. It's called the Cain and the Bell. You can get also it on the internet. Sorry. Oh, yeah, sure. OK, this file was saved. Now we are importing. Yeah. Just need some prevent. Yeah. Okay.
Exactly.
Yeah.
Right. We can let this run in the background when we take questions. I know we ran a little bit over,
just on sync, you can see it's using pre-calculated rainbow tables.
Yeah.
So the chance of recover the password in a small time is pretty big. And you can see here the password recovered is Spider Labs. 12. Yeah, exactly. So we can see how the attack works. Basically, that's the idea of the attack. Well, and now, oops. If you have any question.
Yeah, any questions?
Yeah.
Sure.
What do you think the Oracle is going to do about this? It seems pretty serious.
Oh, so the question is, what do you think Oracle's going to do? Well, they, the thing is about at least the injection package, that is pretty much against anything that doesn't validate the protocol. So the whole reason that works is because you notice where I was showing the checksums were zeroed out. Well, if they threw some sort of secure checksum in there and I started messing around with the packets and they were doing validation using them, I wouldn't be able to do that kind of attack. So hopefully what they'll do is they'll do something with that. They do have a solution that's called like the Oracle Advanced Security or something. We can't say whether it's good or bad. We haven't used it. It's just that's out there. So that might be a possible countermeasure there. I don't know.
That one is extremely expensive.
Yeah, it is. It's an add-on. We're not a big fan of that approach in that you have to pay for security, right? It doesn't come with the product itself. So I'll talk, you talk to, Fortune 500 CEOs and they're like, no, we'll pass, right? A lot of times, a lot of them. So it's, yeah, as far as the flaws we found here, certainly it's all documented. Hopefully they'll take that into account. We're not releasing, this isn't like a vulnerability advisory type thing. This is actually, this entire talk is really around sort of what we see as kind of frontier of finding vulnerabilities, which is where it's not your traditional remote exploit, where you're out and you're going across the internet to hit something. This is kind of an odd thing where we're actually in the middle and we're manipulating the client and the server. We're kind of doing an attack on both fronts. So I think as we start doing more research into man in the middle and what we can do to protocols and how we can mistreat them and how they react, I think we're going to see more and more of this kind of stuff. But I mean, good question. Hopefully, it's documented, so hopefully it gets straightened out. Sure, go ahead.
A couple of years ago, I was involved in developing a vulnerability assessment tool, and it came out that we could do something similar also by downgrading the authentication in Windows and TLM. I think it was for 2003.
Okay.
And also, I think 4 years ago, it was the same on DNC. So maybe you'd like to give it to Windows and also Samba.
Like incorporating that into...
Yes, something similar.
Yeah.
Sure, pretty cool.
Also in Samba, you're doing something similar. You can authenticate using hashing, DAS, or using Kerberos or whatever authentication system. And there is a mechanism where client and server acknowledge an authentication method. And sometimes, I remember it was possible to downgrade it to a simple one, it was DAS, and doing something like that.
Absolutely, yeah.
You should check the Windows authentication. Windows share and also Samba.
Absolutely. So yeah, maybe we can talk to you a little bit about that afterwards. That's pretty cool.
Maybe you can do a follow-up.
Yeah, that's cool. So yeah, I mean, obviously downgrading's been with us for a while, and that's a pretty good, like a back vector in a lot of cases if you want to get, something that's easier to crack. Any other questions? Yes.
Is there a way to configure the client so that they don't use the old protocols or the OWASP protocols?
That's a good question.
No. You are unable. It's inside the Oracle.
To not use old password hashes. And if you weren't DBA, could you select DBA users and pull the password hashes?
Yeah, but I mean, in some way, you need to have the NTLM hashes on the Windows machine.
That's $sign off, so that's OS authentication. You can turn that off too. So I think everything you've seen, you can turn.
Yeah, in theory, you can turn that off, but in practice, it's always travel around the network.
And as far as the Oracle downgrade
How
itself,
many people have their database subnets in a data center the same as the floor subnet where people are working?
I wouldn't
Into a
know.
data center and do that. So
Well, so here's where we find
all
it.
like can.
I can answer that. So the question is, how bad is this if this is man-in-the-middle stuff? And obviously, that is a very good question. I believe that it's a lot more, we see this a lot more than you think. And here's why. Karma attacks, you're going to be getting L2, right? You exploit on our externals. Let's say that you've got the database system, the web balancing going on. You're bouncing off of that. There's nothing getting in. But there's some CMS. There's some broken testing CMS that IT left laying around somewhere else in the subnet, right? Let's say you compromise that. There's a good chance that on the back end of that is something at least to serve a subnet, right? And as you start doing L2 attacks, and start doing layer 2 attacks on the back end of that, then things get interesting. It's usually, so it's like rock climbing. Layer 2 attacks are usually after you've gotten a foothold, obviously. You need to have that first foothold. Any penetration testing or attacking is really like rock climbing. But if you get that foothold, if you get that first step and you're able to get into that internal network, it's a really good go-to move.
I mean, what you're showing here is like, because Oracle uses like Diffie Hellman to throw the password pack. What you're doing is you're getting in and then you're fetching the password hashes out of DBA users or something, right? And then going and cracking them behind after the fact.
That's part of it. Yeah, there's some downgrading going on, but there's also, there's session injection too. So, anyway, sure, go ahead. Yeah, absolutely. Thanks a lot, guys. Appreciate it.
Thank you.